Good morning, everyone. Let's continue our discussion. Today, we'll talk about Spark. This is day one of Spark, and let us understand what is Apache Spark, right? So, Apache Spark is a very popular framework for big data processing. You want to become a data engineer, then Apache Spark is something which you must have in your skill set. Okay, if you want to process huge amount of data, if you want to process the data using open source technology. A lot of companies are using open source technology to write the code to process the data. They really don't want to use any paid, product of XYZ company and pay them for every hours the tool runs. Instead of that, what they believe is let us write everything in open source because we will have a more control in writing the code. That's the importance of any open source technology. Okay, now this is created by a guy called Mate Jaharia. Okay, and whenever I take up a program, I basically showcase you the developer who was the main guy behind this. Okay, luckily he's also in the LinkedIn, and if you are a LinkedIn guys, go and check his name and follow him. Okay, so he is the creator of Apache Spark. I would say initially Spark, later it was given to Apache as a sub project. Okay, now this was released in 2012, which means this technology itself is 12 years old. Okay, so this technology itself is 12 years old. Now he is currently working as a co-founder and chief technologist of Databricks. Okay, so you might have heard something about Databricks. Databricks is another, I would say, ecosystem component in terms of data engineering. Few people work with Databricks, few people work with AWS, few people work with Azure, and so on. So I would say Databricks is another ecosystem component in the field of data engineering. Okay, so we'll talk more about this later, but then our focus right now would be on Apache Spark. Okay, in the course of his PhD studies, he created the Apache Spark project and co-created one more project called Mesos. Okay, and later this Apache Spark became more popular than Mesos, right? Now if you want to understand where should I go and browse more details, then you have a website spark.apache.org. Okay, just you can go there and then play around with the UI. You will see a lot of documentation, you will see a lot of stuff, you'll see how to download the software. We'll see that in the coming days. Okay, now you may ask me, why do we actually need a Spark? What is the reason behind picking up this Spark? Is it wise enough to learn Spark in 2025? You may ask me this question, right? But I would say yes, it is absolutely worth it because Apache Spark is so popular in terms of data engineering that every company who are working on open source, they have Apache Spark in their code base. Okay, even not just that, people who are also into the data science field, they also are pretty interested to work on Apache Spark. Okay, so they also play around with some small data set, and then later they feel, okay, let us start solving the similar problem in terms of big data. Their go-to tools by default most likely would be Apache Spark if they have a big data in their cluster also. And most likely, if you say I work as a data scientist, that means your company definitely would have a big data environment. Okay, maybe you have not used it, but it would be there in one or other way. So there are few popular framework to solve the problems in terms of big data. The very popular was MapReduce, and it has ruled the market a lot. Okay, MapReduce was the framework which has ruled the market a lot. Then we have another tool called Tage. We also had something called Strom. We have a Spark. Now these days you will see people talking about MapReduce very less, but you'll see everybody would talk about Spark. Okay, now why it is so popular? If you look into the MapReduce is basically used for batch processing. Okay, MapReduce is basically used for batch processing, but if you want to do a interactive processing or real-time processing or iterative processing, then MapReduce is not a good fit. What do you mean by interactive? Interactive means during your code you should be able to talk to the framework for your decision making. For example, when you're processing a job using Spark, many times you may say, I want to take the feedback from the user and I would process according to that. Also can be done in terms of interactive. Okay, real time means it has to be completely real time. For example, you're building any product for credit card fraud detection, or maybe something which should be streamed in the real time. Okay, so in those cases you would basically need a real time processing. Okay, for example, let's say Republic Day is coming up, and then you would like to set up a framework which will allow us to check the tweets or personal messages, or anything else, and see if there is any potential threat. For example, we know that WhatsApp is end-to-end secure, right? But what if the Indian government says we want us to read this information because we want to see if somebody has unwanted intentions, right? In that case, we should be able to process this data in nearly real time. The moment I message somebody like, let us put a bomb in XYZ area, I should be caught, right? So the process should happen in that much real time. Okay, iterative means most likely when you are doing a classification problem in data science and all. Okay, you would like to run the same data on various different algorithm one by one. Okay, and you would like to classify whether this is product A or product B or product C or product D. Okay, for example, let's say you got one object, and now you want to identify whether this object is a bird, whether this object is a mammal, whether this object is basically an animal. Okay, whether this object is basically something which lives under the water. Okay, maybe based on various category you would like to label it. Okay, now in that case you'll run your code on that object, multiple code you'll run on the same object again and again, and you'll try to collect the points. How much point you get when you say it is a bird, how much point you get, or how much closeness you get when you say it is a animal or it stays under the water, and so on. So those kind of problems comes under your iterative approach. That means it's a kind of loop which will iterate for n number of times. Okay, now a very common question that people ask me every now and then is like, do we still have MapReduce at work? This is a very common question many people ask me, and I would always say yes. Okay, yes. So we have MapReduce today in real world. We also have Spark today in real world. Okay, can you justify this? MapReduce is very good in terms of batch processing, and you really don't need a big number of computers, a lot of memory, that is RAM, to do your MapReduce job, because we know that MapReduce is basically what? Disk IO job. Okay, MapReduce is basically disk IO job. What do you mean by that? That means when you run your MapReduce code, it loads the data from the disk, okay, and does some processing, writes the data back to the disk. Again, if you write another MapReduce job, again it picks the data from the disk, again processes it and writes the result back to the disk. Okay, so this kind of requirement will always be there in the industry, which means the MapReduce is not going anywhere. Okay, but when I say MapReduce is not going anywhere, I'm not saying that you'll start writing the MapReduce code these days. Probably you will not do that. Okay, but if you have ever worked on something called Hive, you might have seen that Hive has a feature wherein you can run this Hive. You can change the engine of Hive to run on Tej, to run on Spark, or to run on the traditional MapReduce framework. Okay, now tell me one thing. We all do one or other shopping through credit card, right? And every month we receive our credit card bill. Okay, now what do you think should we use? Should we use a MapReduce job to create the credit card bill, or should we use Spark to create the credit card bill? What would you do if you are working as a product manager and you are required to implement a code or a feature which will help us to process the credit card bill of every user and send an email to them with a attached PDF? What would you choose in that case? What do you think you should be doing? In that case, you would write a MapReduce job. Okay, when I say MapReduce job, again I'm saying it's not necessary that you are going to write the MapReduce code. It could be you would write some sort of code which would run on the MapReduce framework. Why? Because you don't have a requirement to get them immediately right now, right? You don't have a requirement to process that right away. Okay, and Spark would be very, very costly. Spark would be very, very costly. Why? Because think about this. If you are given a task to set up 10 node cluster, okay, if you're given a task to set up a 10 node cluster, 10 machines put together in a cluster, okay, and you would say, okay, let me have 1 TB of hard disk, and let me have, let's say, 16 GB RAM, okay, and let me have four cores. Okay, now this is the configuration of one machine. So my job was to create a 10 node cluster, and each node, that means each machine, would have 1 terabyte of hard disk, would have 16 GB of RAM, and would have 4 cores. Okay, now if I go by this formula, then altogether I'm gaining what? 10 TB of hard disk, 10 TB of storage, okay, and 160 GB of memory, okay, and 40 cores. This is what you are going to gain when you prepare your MapReduce cluster. Okay, what is the advantage? It would be cheaper, right? And you don't need the output immediately. Let that run for 5 hours, let that run for 8 hours, let that run for 24 hours. It's absolutely okay, right? So there are so many jobs that demands a MapReduce job. Okay, for example, if I go to my bank and if I say, hey, I want to get my transactional data, I want to get all my 10 years bank statement, because I have to produce it to the Indian code for whatever reason, right? Now in that case, the bank should coordinate with me, okay, and it has to give me the report of my last 10 years of transaction. Now think about this, last 10 years of data only for a customer's data. Don't you think you have to work with a lot of data? You have to process a lot of data just to fetch my data? Of course, yes, right? Now in that case, it would still use a MapReduce job. It would say, give us a time of 7 days. It does not say come tomorrow, right? It will say, give us a time of 7 days and we will process the request. But at the end of the day, they would basically run a MapReduce job. Okay, they might run a hype query, they might run some other query which would utilize the MapReduce job, because you really don't have urgency here. If there is an urgency, then it has to be migrated on Spark job. Okay, so are we clear what is a MapReduce job here altogether? Why it would be still used? So that is what it is, right? So when you are processing your data using a MapReduce, it would take a lot of time, and it is absolutely fine. It depends on the requirement whether you would run your Spark job or whether you run your MapReduce job. Okay, so as I said, in the company today we use both Spark as well as MapReduce. Spark if you want the result immediately, and MapReduce if you are okay to wait. And a lot of jobs today are still running on the MapReduce mode because of that. Now, what is a batch processing? As I said, the batch processing is basically a process that we do typically on historical data, right? As I said, like if I say I want to get the report of my last 10 years bank statement, that means I want to work with the historical data. Historical data are huge, right? And because of that, if you have to process your historical data, then you would use a batch processing. Okay, now interactive, if you want to have an interactive processing wherein, as I said, you want to ask various questions to the end user through the framework, the end user would enter yes, proceed in that direction or this direction and all, you can use Spark for that. Okay, now we have already discussed iterative also, which means during the classification and all, you would like to categorize that, you would like to run the same code base again and again on the same object and get some labeling or classification out of it. You'd use iterative, right? Now one thing that is very popular these days is real time, right? So what is a real time? Real time processing is done on the data which would need the attention immediately. Okay, how much immediate, that depends on your requirement. Okay, now earlier when Spark came into the market, when I was using MapReduce in the initial days of my career, right? So the MapReduce was the only choice we had, and then we had something called Storm. Okay, but I did not get a chance to work on this because by the time I moved to the real time, we had already Spark included in the tech stack. Okay, so earlier there were people who are using MapReduce plus Storm for batch and real time processing, but these days industry have started using Spark plus MapReduce. Okay, now industry still uses MapReduce for batch processing as it is proven solution, and it may take some more time for Spark to prove its capability fully for batch processing. So today, if somebody says we use only Spark at job, that means they are working on some data which is not that big, which is really not that big. If somebody says we process 40 terabytes of data, 100 terabytes of data, Trust me, they are using MapReduce job behind the scene. Okay, because the Spark framework itself would be very costly to implement. Why? Because you know that Spark is basically in memory. Spark processes the data in memory, which will make it very, very costly. Okay, and you cannot even estimate the cost. That cost is so high. People say cloud is cheap. No, cloud is also super high. It costs you a lot of money. Okay, maybe for you it looks from company point of view it might be cheaper, but it would be super high. It would be more than your salary and my salary monthly, yearly, sorry. Okay, the monthly bill of cloud would be more than our annual salary, trust me. Okay, now earlier we had also a component called Mahot for machine learning, but now Spark also has come up with their own machine learning library, and it is so popular. Okay, so these days you can do everything using Spark. If you have money, you can do everything using Spark. Okay, now let us take some use case. I've taken some of the use cases that I have worked in my previous job. Okay, for example, Apple uses Apache Spark on Scala to build Apple Maps. You know Scala, you know Spark, you are good to get a job in Apple. You don't have to work on the fancy cloud and all. We use that very minimal. Okay, we use cloud only to deploy, but our all code base actually are built on Scala based Spark. Okay, Optum UHG again uses Apache Spark to maintain the list of all the hospitals, equipments, and its association. I have worked on Optum, wherein we were building a project called Intelligent Directory, wherein we would list down all the resources, everything available in a hospital across US, which will help the customer to understand which hospital has what doctor, what nurses, what are the equipments, and everything available. Okay, why? Because in US you cannot just ask a patient to come and say the doctor did not come today. That's a crime in US. Okay, in India it's chalta, but then it's a big crime in US to just ask the patient to come and say we do not have a doctor right now, or he's on the way, and so on. So we wanted to create a directory which would give us a real-time analysis on what kind of facilities are available or what kind of resources are available on a particular hospital. Okay, so use case looks simple, but the implementation is not at all simple. We had 40 people working together, including 4 Scrum Masters, 3 project managers, and so on. Now, Credit Vidya, a company where I worked, uses Apache Spark to predict the score of a customer who do not have a credit history. Let's take an example. You go to a bank and you say, hey, I want a loan. Now the bank would ask you, where do you work, sir? And you say, I work for XYZ. Then the bank would ask you, okay, do you have credit card? No, sir, I have not at all taken any credit card. Any home loan? No, sir, I do not have any home loan. Okay. Now, when you have not taken any credit card, when you have not taken any loan, we don't know your credit history. We don't know what is your paying capacity. Will you pay back? Right? So it's very hard to give you a loan. But if you have already taken a home loan previously and you have already paid them in time, then you will see getting another loan is not at all that difficult. Okay, so Credit Vidya, where I worked previously, we used Apache Spark on Scala to predict the score of a customer who do not have a credit history. A lot of parameters are included. We'll talk about that in the coming days. Likewise, you can see a lot of use cases like credit card fraud detection, wherein you are doing a lot of transactions, and based on the behavior of the transaction, your system would be able to identify if it is a fraud. I'll give an example that happened with me. I was buying a flight ticket. The transaction did not went through because of some reason. Okay, but I have to book my ticket because I need to go. Right? I tried 2 more times and the transaction was not through, probably because of the technical error at the other end. But the bank was quick enough to give me a call saying that, hey, we can see that you're trying to do a transaction of 20,000 3 times. Was that you or was that somebody else? Right? So it means a repetitive transaction, okay, of same amount, right, at particularly same time frame. Is not it? That means it is still smart enough to understand if this could lead to a fraud. It's not it. So that is how it was. And I said, yes, it was me. And then the transaction happened smoothly. Okay. Likewise, you can see those in the weather forecasting as well. So a lot of people are using the weather forecasting report, and we all use that, right? But at the end of the day, there are some stations which actually picks up a lot of parameters. And think about this: the weather forecasting happens couple of times in a day, right? 3 to 4 times in a day. So at that time, you may want to give the result immediately, as soon as you can. You might not be happy to say, okay, I've taken the measurement at 2 o'clock, 2 a.m. early morning. I'll give you the report at 6. That does not work out, right? So in that case, you need to actually give the real-time result. Okay. Now, healthcare analysis. In healthcare also, it is very important, because suppose you're investigating a patient and you would like to know if certain things goes out of the bound, you should basically get an alert. Okay. If that kind of system you want to build, definitely you need a healthcare. You would definitely need a big data processing if you want to process them very smoothly. Financial risk estimation. As I said, what is the guarantee that you will pay me back, right? So if that's the case, then you would need something. It could be Spark, or it could be something which can actually work on the nearly real time. Okay. Now let us talk about the next limitation of MapReduce. MapReduce was doing so good, was so popular. I myself have written a couple of MapReduce job, which is the toughest job in the world of big data, right? So people are scared of writing the mapper code, the reducer code, the shuffle and sort, and all. But there was a time when we had done that to solve our problem statement. So what the limitation of the map? The first limitation of the MapReduce is each phase, like you have map phase, you have shuffle and sort, group by, and whatnot. All these phases needs to write the data in the disk every time. Okay, needs to write the data in the disk every time. The IO operation is huge, and the IO operation takes a lot of time. Think about this. You might have noticed when you have your laptop and when you transfer a small file to your pen drive, right? A small file to a pen drive, you will see it takes some time, right? And that file may be hardly of 100 MB, 200 MB, or 1 GB, or let's say 1 GB. It takes good time to transfer 1 GB of data from your disk to your pen drive, right? Now think about this. In the real world, you're not going to deal with only 1 GB. You're going to deal with 100 GB, right? So those kind of data, when you try to bring it to the memory to process every time, right, it takes a lot of time. And your IO operation actually reduces the speed of execution by at least 100 times, because bringing the data from disk to memory, memory to disk, and so on would actually take more time than the time taken to process your data itself, because the data is huge. Okay. Now when you have a multiple MapReduce job chaining back to back, the output of each MapReduce is written on SDFS, which is nothing but written on local file system, not into a RAM. Again, this creates a lot of IO operations to and fro from the disk. Okay. And MapReduce can work on historical data, and because of the slowness, it cannot be used to process real data just in data. It is best fit for batch processing. Okay. And again, I'm not saying that MapReduce is outdated, nobody uses it. It is used. It is used in the industry, okay, where we have a huge amount of data. Probably the company where you work, you check the data size and see what kind of data you are working with. For example, if I say Facebook, let's say Facebook generates 1 TB of data every day, let's assume. Okay. But that 1 TB of data would be processed using Spark. Why? Because 1 TB of data is not a historical data. It is a just in data. And if it is a just in data, it has to be processed. But if you try to think about Facebook historical data, then it would be very, very huge. Okay. Now, look into this small diagram. This small diagram tells you the whole story. You have your input data, which is in the disk. You have written your MapReduce code. Okay, it processes the data and it throws you the output back into the disk again. Again, you have written another MapReduce job, which would pick up this data and would process and again throws the data back to the disk. Again, you have written MapReduce 3, okay, which would pick up this data, which is again from the disk, processes it, and again throws the output to the disk. Finally, you have a MapReduce 4 data, which picks up the output 3, which is again from the disk, processes that and throws the output back to the disk, and this is your final output. So if you look into this example, you see a lot of IO operation is happening. Okay, you see a lot of IO operations are happening every now and then. Okay, now let's talk about a benchmarking. So when Spark was built, they wanted to check how good it is with respect to the MapReduce job. Okay, so what they did, they took up a requirement and wrote a code which would run on MapReduce job as well as would run on Spark job to see the speed of it. Okay, now there was a MapReduce job which was executed in one iteration and it took 110 seconds, where Spark took 80 seconds. So as I said, during the benchmarking, okay, the people, I don't have that code base, I would love to showcase that otherwise. What they did is they wrote a small MapReduce job and executed in one iteration. One time they executed that and it took almost 110 seconds, whereas the Spark took 80 seconds, which means they are very equivalent, right? One requirement, your MapReduce took 110 seconds, Spark took 80 seconds. But then what they did is, but the same MapReduce job with 30 iterations, that means it's basically a problem of classification, okay, wherein it was executed 30 times and it took almost 3500 seconds, whereas in Spark it took only 80 seconds plus 29 seconds, 1 second for each iteration. Why it took so less time is because Spark processes the data in memory. Okay, once the data is loaded in RAM, the data would be processed in the RAM, the temporary output would be stored in the RAM, the next job would take the data from the RAM, and so on. Okay, so the whole job would run on the data being still on the RAM, and that makes it faster, nothing else. Okay, if MapReduce had similar capability, then there would have no difference between MapReduce and Spark. The biggest differentiator between MapReduce job and the Spark is MapReduce always writes the data back to the disk after every operation, as shown in the diagram. See this diagram. Your MapReduce one reads the data from the disk, processes that in the memory, and throws the output back to the disk. That's the problem. Okay, whereas the Spark will not throw the data in the disk. The Spark will keep the data in the memory itself. Okay, which we will see as we move on. Now, Spark was coded in Scala, which is short and precise. Therefore, the Spark entire source code has around 20,000 lines of code, whereas Hadoop 1 has around 90,000 and Hadoop 2 has 220,000 lines of code. But lines of code should not be a big deal. Okay, now Spark is completely written in Scala, and I would say it makes more sense to learn Scala with Spark. Many of us are making a big mistake, that is, we are learning Python and Spark. Why? I'll tell you that in some time. Okay, now I'll not be reading this theory, you just go ahead and then read that. Let's spend time with the reality altogether. How is your Spark super fast? Okay, that is the first question, right? The short answer would be because it is a in-memory, number one, and they use a very advanced DAG. I'll show you that DAG as we start writing the Spark job. Okay, I'll show you how the DAG looks like, and you will be mastering the DAG over the period of time. Okay, it comes with a very advanced DAG, a data processing engine. What it means is for every Spark job, a DAG of task is created to be executed by the engine. So DAG is just like a graph. Okay, DAG is just like a graph which shows, okay, this is what it is. Step 1, step 2, step 3, step 4, and so on. So the entire graph is called as a DAG. Okay, so DAG is basically a graph which has the vertices and all. We'll see that in case of when we start doing a practical. Okay, so Spark is very fast because of two reasons. Number one, it is in memory. That's the biggest thing that we see. The second thing is it follows a concept of DAG, and it has the capability to run the job from the place where it failed last time. It also has a concept of caching. Okay, we'll see that as we move on with the program. But if you ask me why Spark is super fast, number one, in memory. Number two, runs on the DAG, which defines the steps very clearly. And I would also like to include one more point here. We have a concept of caching, and we'll see that in the coming days. Now, will Spark replace Hadoop? Very common question. Okay, many people are still confused in 2025, and they will still be confused in 2027 as well. So the Spark is just another processing framework, just like your MapReduce. Okay, and as I said, your Spark and Hadoop are not at all a competitor. If you ask me how they are related, see here. When Hadoop was created, Hadoop came up with some component. We call it SDFS plus MapReduce. Okay, the initial version of Hadoop has two parts: SDFS, MapReduce plus, I would say, YARN plus YARN. Okay, so if you ask me what is Hadoop, I will say Hadoop is nothing but SDFS plus MapReduce plus YARN. What is SDFS? A disk storage, Hadoop distributed file system. What is MapReduce? A processing framework where you write a code. What is YARN? YARN is basically a network negotiator, or you can say a cluster manager. Okay, so this is what it is. Now, because of Spark introduction, it has just replaced the MapReduce part of it. It has just replaced the MapReduce part of it. So if you ask me, is Spark a replacement of MapReduce? I will say yes. If you ask me, is Spark a replacement of Hadoop? I would say no, because we still use SDFS. We still use YARN. Okay, so this framework is only replaced. Rest SDFS, we still have SDFS, we still have YARN. Okay, so let's look into this. Spark is just another processing framework like your MapReduce job. Spark does not have its own storage system like SDFS, so needs to be dependent on Hadoop. So Spark can only process, it cannot store, right? Its job is give me the processing framework, I'll pull the data from that and I'll process it and tell me where to write. Okay, now because of this, the Spark is not a replacement of Hadoop, it's just a replacement of MapReduce. Okay, so your Spark does not have its own storage system like your SDFS, so it is still dependent on Hadoop for SDFS. Next, Spark does not have a cluster manager like YARN, but has a local manager, and hence it is still dependent on Hadoop. So, which means if any company is using Apache Spark, there is 200% guarantee that they have also installed Apache Hadoop. Okay, they are just replacing this MapReduce with Spark and nothing else. Okay, so it heavily depends on Hadoop for storage and cluster. In the real time, Spark component is deployed on Hadoop cluster. Okay, you'll see a lot of scenario where you write a Spark code, you have created a jar file out of it, and that jar file is deployed on a Hadoop cluster, right? The only difference is we are replacing MapReduce, nothing else. Now, in many companies, Hadoop and Spark both are used together, whereas Hadoop is used for batch processing job, whereas Spark is used for real-time job. So in certain companies where you are a data engineer, your requirement would be to write a program that can process huge amount of data and solve it. Okay. Now, when you write a program, you are given two choices. What kind of program you would like to use? If suppose you are working on some relational kind of database like Hive and all, or if you have a relational data, or if you have a data which can be represented in a tabular format, you might load that data in Hive and you may feel, I don't need a Spark cluster for this. Let me use my Hadoop cluster to run a job. Okay. Likewise, there could be some job when you feel I would run it on a Spark cluster. So let me run it on a Spark cluster. Okay. It is very much possible that you have joined a company, let's say C. You are given a project, let's say P. Okay. And your project has total 10 people. And all these 10 people are working on some job which would be a Spark job. So what you are given is you are given Spark cluster. You're given a cluster where Spark is installed. And you guys have no idea that there are 5 other Hadoop cluster available. And you have no clue about this because that's nowhere related to your project. You will not know the infrastructure of the entire system. Even all these companies wherever I have worked till today, I had no complete knowledge about all the infrastructure. And why would I? Because I'm not a DBA guys, or I'm not a DevOps team that I should worry about the infrastructure of a company, right? I would be worried about my infrastructure where I'm going to work. What is the total number of nodes? What is the configuration of each machines that I should be worried about, but I should not be worried about the entire cluster. Okay. Now let us include one more point here: Scala with Spark or PySpark. You may ask me a question, Suraj, what should I pick up? I want to become a data engineer, or I'm learning data engineering, and I see there is a little confusion here between these two. Should I learn Scala with Spark or Python with Spark? Now the question is, when you say PySpark, can I say it is Python with Spark? Yes. Okay. Now tell me one thing, which one would be easy to learn out of these two? So see, few people may say Python is easy to learn, few people may say Scala is easy to learn. But let me tell you one thing very honestly, guys. The thing is, both Python and Scala would take same time to learn. It takes same time to learn. The only thing is, you have not seen the extensive courses. For example, if you just go to tutorials point, and if you pick a Python tutorial, if you pick up Scala tutorial, they are of same length, of course, right? But what I can do in Scala, let's say I can write a multi-threading program using Scala. Can you do that in Python? Yes, right? We work with object-oriented concept in Scala. Can we do that in Python? Yes. Which means we have a collection in Scala. Do we have collection in Python? Yes. Which means both these two would take same time to learn. The only thing is you need to have a good teacher. Okay. So Python or Scala both would take the same learning curve. Even if you say Java, same learning curve. Any programming language, if you are learning it sincerely, would need same learning curve. Okay. Now tell me one thing. This Apache Spark is built on which programming language? It is written in Scala. It is written in Scala. Okay. Which means what happens, when you write your PySpark, and that's going to talk with your Spark framework, which is built on Scala. Okay. There would be a wrapper here. Do you agree with me that there would be a wrapper? There would be a wrapper here to talk to the JVM, because your Spark is written on Scala. Scala is a JVM based language, and this is your Python code. Your Python cannot talk to JVM, not at all, not at all possible. Okay, your Python cannot talk to the JVM, so there would be a wrapper in the middle which says, hey, this is the Python code, I'll convert that to a JVM equivalent and let me run it there. So do you agree that this little step would add little overhead here? Do you agree that this little step would take little overhead here? Which means, can I say your Scala, your PySpark code will be little slower than Scala Spark? Of course, yes. Okay. So your PySpark code will be little slower. And that is the reason, if you talk about big companies, they work on Scala based Spark. Okay. So if you look into companies like Google, Apple, Microsoft, what these guys do, for building all their great platform, they use JVM 200% sure. Okay. Whereas these guys have a lot of other projects which is not so important as their core platform. It's okay to be a little slow, that's fine. They would use other framework. Otherwise, let me ask you a question. Why would Microsoft hire a Java developer? Just search it in the Google if Microsoft has any requirement on Java development or not. If yes, then why are they even hiring Java developers? Right? When they have their own platform like C Sharp and all. Okay. Likewise, as I said, I worked with Apple for 2 years, and there we use Scala based Spark. We don't entertain Python. Reason is because it is too much slow and we cannot actually rely on building a platform. We invest a lot of money, and at the end of the day, we don't want to get a product which is relatively slower, right? So we would like to choose the best possible framework available in the market. Okay, and that is why I would say start learning Scala. Scala with Spark will make you irreplaceable at work. You may say, I see there are 100 requirements for PySpark, and you may say there are 10 requirements for Scala Spark. You may say this. Now, in this 100 requirements for PySpark, most of them are projects. Most of them are projects, less product. Okay, I'm talking about the percentage. Most of them are projects. Plus, when you apply for this role, when you prepare for this role, do you agree with me that all the people who have taken a course on data science who could not make it into the data science would also come up for this requirement. Okay, so one is this is a project. The second thing is this is a data science learner who would also apply for this role. Versus when you are looking into this 10 requirements for Scala Spark, okay, they are building products, okay, and you will get only core engineers. So if there are 100 requirements for PySpark, you will see at least 10,000 people applying for this post. Whereas if there is 10 requirement for Scala and Spark, you will see very few, let's say 8 people applying for this post. Okay, now you decide which one you would learn, because see, you don't need 10 jobs, you need only one job, right? And you would like to get a job which would help you tomorrow to make more money. And of course, if we talk about the salary, compare the salary of this guy and this guy, you will see this guy is making more. Okay, when I say this, let us not say I have a guy who is a Scala developer at TCS, and I know my friend who is working as a HTML developer in Google, and you will say he is making more money. Don't compare it like this. You are wrong. You're comparing it in a wrong way. When you want to compare the salary of a Scala Spark developer versus PySpark developer, compare the same company, compare the same experience, compare the same designation. Then you'll get the clarity. Okay, so which means Scala with Spark would be used in product based companies where they are working with Spark, and Python with Spark is mostly used in building projects. Nothing is wrong. Okay, it's up to you what you want to do. You want to use this or you want to use this. Learning curve wise, as I said, Python as well as Scala both would take the same learning curve. Okay, you may say, hey, I've taken a course from XYZ wherein I learned Python for a week. That is like you have just learned the basics. That's not the complete Python. Even if you want to learn the Python seriously and sincerely, it will take at least 2 to 3 months just to learn the Python. Same cases for Scala as well. Even if you want to learn Scala, it will take 2 to 3 months to learn the Scala. Even if you want to learn Java, it will take 2 to 3 months to learn Java seriously. Okay, so learning a programming language will take at least 3 months, minimum 3 months, no matter what are you learning, whether you are learning Python or whether you are learning Java or whether you are learning Scala.